So, the title of the talk today by our esteemed speaker is Machine Learning in AdTech. So, over to you, Ritika ma'am.
Thanks, Swati, for having me here. So I'll quickly share my screen.
Yes, sure, ma'am.
Okay, is my screen visible?
Yes, ma'am. Yes, this is good.
Okay, great. Hi, everyone. Welcome you all in today's session, Machine Learning in AdTech. And happy Women's Day to all of you. So let's get started. So as we have variety of experience and exposure to both machine learning and AdTech, I'll be starting off by creating a baseline. Initially, I'll be discussing about AdTech industry, like how it got evolved and some of the strategic changes which have happened over a time. Later on, I will be discussing about how machine learning works at PubMatic and some of the use cases like where we are applying machine learning to solve some of the challenging problems. And in the end, we will be discussing about two specific use cases in detail. So let's get started. So in this section, with the help of this diagram, I will be creating a context about how an ad tech industry is like how an ad gets served by taking you through the various entities which are involved in serving an ad. So initially, when any user visits any website or an app, a relevant ad gets served to him or her. So over here, the website is referred as a publisher. So publishers make their inventory basically available to the sales side platform, which is referred as SSP. So each time the publisher web page gets loaded, the ad request basically get to our platform. So PubMatic being an SSP, any questions? Okay, so PubMatic being an SSP is integrated to the demand side platforms and various other entities like advertisers, agencies, network exchanges, etc. So the platform basically conducts the real-time auction in 100 milliseconds in order to put the most relevant ad in front of the user. So after looking at how the ad gets served and various entities involved in it, let's quickly understand the objectives and goals behind each entity in the ad tech value chain. So on the demand side, we have advertiser here, and on the sell side, we have publisher. So the objective of the advertiser is to create a campaign goal in order to increase the brand awareness and drive the sales. And for the publisher, the objective is to get financially rewarded for the audience they garner. So in between the advertiser and the publisher, we have bunch of entities. So advertisers basically connect to the agencies who help them to manage their campaign goals and also beat their campaign goals. Agencies in turn connect with the demand side platforms. So demand side platform or DSP generally use real-time bidding RTB in order to achieve the campaign goals at a lower price. So they basically help to increase the return on investment for buyers. On the sell side, publishers integrate with the sell side platform like PubMatic, who also use real-time bidding in order to connect to the incremental demand to grow their revenue or yield, basically. So, like this is how the SSP facilitates the AdTech ecosystem. Now, here I will be going through the evolution of the SSP. So in early 2000, SSP used to serve as a middleman between the buyers and the sellers, and they used to backfill basically. So they used to basically programmatically monetize the unsold inventory. Later on, around 2006, roughly when PubMatic got formed, the SSP shifted to become a technology provider for the publishers, and they helped them to they helped them to basically drive the marketplace efficiency programmatically. And over the years, we have developed a lot of comprehensive solutions in order to uh, increase the monetization programmatically. We have built a header bidding solution for the publishers or media buyer consoles for the buyers to increase the ROI or yield. And more lately, programmatically, buyers embrace SSP as an omni-channel solution where we deliver greater programmatic revenue to the publishers. So the mission statement for us is that PubMatic delivers superior revenue to the publishers by being an SSP of choice for agencies and advertisers. So PubMatic is a global infrastructure which enables real-time bidding and digital advertising transactions. So we have deployed our network equipment, software, hardware, and ad servers around 8 data centers around the world. And each ad generates tremendous amount of data. And this, at a glance, this corresponds to 134 billion ad impressions per day, which corresponds to 1 trillion advertiser bids per day. And this roughly generates around 1.65 petabytes of data daily. So that's pretty mind blowing. Now, after looking at global footprint, let's look at. Hello.
नाही, मी मशीनवर आहे ना तुमच्या.
Excuse me, there is some disturbance. Can you guys mute? Okay, yeah, let's go ahead. So after looking at global data footprint, let's look at how we are solving some of the challenges related to scale and complexities. So our big data cluster basically harness massive data decisions in real time. Going ahead, let's look at some of the key focus areas of machine learning. So there are four major areas, namely bidding, traffic management, pipe cleanliness, and sales enablement. In the bidding section, we will be looking at how we are applying machine learning and auction theory in order to increase the ROI for the advertiser and also the publisher yield. In the traffic management section, we will be looking at how ML is helping us to reduce the infrastructure cost for tech vendors and also for the intermediaries, which we have seen earlier. In the pipe cleanliness section, we are using machine learning in order to increase the richness of the data transferred and also to reduce the systemic errors. And in the sales enablement section, we are using machine learning to create recommendations in order to improve the efficacy for our customer sales team. So today I will be discussing about two categories in depth, which is bidding and traffic management. So let's go ahead. So before going into specific areas, let's look at some of the challenges which we have. So massive data set is like we have already seen at what scale we are operating at. So every day we have terabytes of daily raw data. So this corresponds to millions of sparse feature and also very high cardinality features. Second major challenge for us is like rapid changing data. So AdTech domain has a very dynamic environment, and the data distribution changes rapidly over time. Also, the performance of the model decreases as the delay between the training set and test set increases. So we need to refresh our models like very frequently. The third one is the data skewness. So training data over here is highly skewed. Like this corresponds to like only like 1 to 2% of positive cases are there in training set. And the fourth area where we are observing challenges like being real time. So the auction needs to be closed within milliseconds. So going ahead, let's look at traffic management as the first topic for the day. So here we will be looking at how machine learning is helping us to overcome the challenges posted by ever increasing volume of ad impressions. So QPS management or query per second management is the one of the solution in the traffic management section. So as we have already seen, like how PubMatic interacts with the demand side platform in order to serve the ads. With the ever increasing volume of the ad impressions, DSPs have seen their infrastructure costs rising as well. And often demand side platforms have QPS threshold or query per second threshold defined at their end. So this tells us like how much volume they can handle, so that we can protect their systems by from getting bombarded with more queries. And another major requirement is that they want to discard the low value traffic, and in order to focus their infrastructure investment on high value traffic. So the use case over here is like as an intermediary, I would like to curb the infrastructure investment and increase the utilization of existing machines with the valuable traffic. This will become more clear with the help of the diagram. So here on the x-axis, we have time of day, and on the y-axis, we have QPS threshold, which is query per second. Now the red line, which you can see on the graph, is basically representing the QPS cap or the ideal volume which they can handle. And the blue line basically over here shows the actual QPS. So basically, the blue line over here, if you can see, is fluctuating over the time. There are times when there is a flooding or system is getting bombarded with more queries, and there are layer in order to react to the QPS fluctuations using machine learning. And this basically helps us to figure out the pockets of inventory that can be throttled to stay within the QPS threshold given to us, allocated by the DSP. So I hope the problem statement is clear. Let's look at the solution, like how we are solving it. So in this space, we have developed a custom solution using reinforcement learning principles. So we basically predict traffic patterns in order to cover for the data and for the delays, basically execution delays. Secondly, we sort this traffic based on the expected values. And then we basically block or enable traffic based on the threshold and the predicted value. So QPS management is like very effective solution for managing the traffic and also utilizing the existing machines with a valuable traffic. Now the second topic for the day is bidding. So bidding is very interesting area. Today we will be firstly understanding like how real-time bidding happens and how auction basically works, and how it has evolved over the time. And this will basically help us to understand the need for the supply path optimization and how we are solving it using machine learning. So real-time bidding. So real-time bidding is basically a protocol between the SSP and the DSP. We also, like in short, we call it RTB. So this basically helps the advertiser inventory, to be bought or sold on the per impression basis. And this happens instantaneously in the programmatic auction. This is something very similar to the financial markets. So I will be explaining about real-time bidding in 4 simple steps. So initially, whenever any user visits any website, it gets identified and get introduced to the SSP with its context. So context could be it visited its main page, or it's doing some email, something like that. So once we receive this information, we describe this user and its context to buyers, mainly DSPs. So if the DSPs are interested to serve an ad to basically, so they will select a relevant ad and determine its bid price. Now the PubMatic, being an SSP, host auctions and it maintains the SLAs in order to provide a proper experience to the user. In all the 4 steps, we use terabytes of transactional, contextual, and behavioral data in order to improve them. Now, after understanding like how a real-time bidding works, or like how SSPs send requests to multiple DSPs, and how an ad gets served, let's also look at how a publisher gets integrated to SSP. So initially, publisher used to integrate to the single SSP in order to sell their inventory. Over the time, publishers have figured out a way to extend this model via waterfall setup by adding more and more SSP. So if the first SSP is not able to programmatically fill it with ad impression, it used to get passed back to the second SSP or third and so forth. Now, the major drawback of this particular setup is that once the SSP closes the auction, the publisher is to never realize the highest bid, basically. So in order to overcome this challenge, there is an alternative strategy, which is like header bidding setup. So this is more advanced programmatic advertising technique. In this scenario, the publisher is able to share its ad space or its inventory to multiple SSPs in the given time. So the benefit of this strategy is that sellers are able to create more competition among the SSP, which helps them ultimately to drive up their yield. So after looking at like how the inventory, is getting shared, how it has changed over the time, with the evolving gets closed, however, at the highest bid. However, the winner has to pay less than their bid price. So in this example, you can see there are 3 advertisers where advertisers see bids the highest, which is $4, and it's the winner. However, it has to pay the second highest bid plus a penny more, like $3.01 as a clearing price for the inventory. Now, there is a shift from second price auction to the first price auction. Here in the first price auction, the auction get closes for the highest bidder, which is same as second price, which is $4 in this example. However, it has to pay the same amount, like the advertiser C has to pay $4 as the clearing price for the inventory. So with this transition from the second price to first price, buyers basically have to stop bidding by thinking like how much they are willing to pay, and start bidding with a mindset of how little I have to pay for this inventory. So after looking at how the header bidding and first price auction have changed everything how it used to happen. So this has also escalated the need for the improvement in the bid effectiveness. So this problem will get more clear with help of diagram. Like here we are looking at how to improve the bid effectiveness basically. So on the x-axis we have the bid price, and on the y-axis we have the closing price, which is mentioned, or the clearing price. So earlier the auction used to close at the second price auction, which is the blue line. Now the auctions are getting closed at the first price auction, which is the red line. So you can see there is a gap over here, which is the lost ROI. So the use case over here is like buyers wants to maximize return on their marketing investment by intelligently optimizing for results that matter to them. Now the SSP have traditionally SSPs have never played a very strong role in impacting the ROIs for buyers. However, for buyers who are looking for increasing the ROI on their advertising budgets, PubMatic's ROI sync basically automates the optimization of open exchange price. Now this solution for this use case will become more clear later. So here, we have explained it like how entire chain works in this particular problem. So ROI sync is we will be looking at this strategy. So buyers initially determine campaign performance goals, and they send it to us in the form of a bid stream. Now the machine learning platform leverages this data and creates the predictive bidding algorithms. Here we are using multi-arm banded strategy for the exploration and exploitation. And ROI sync models basically adjust the DSP bid price in order to improve the campaign performance strategy. Through this, we have observed 40 to 50% of improvement in ROI across the open exchange price. So the solution is very effective in this supply path optimization, and also this has helped to increase the publisher yield. So this is how PubMatic is, harnessing massive data sets and also leveraging machine learning algorithms to solve problems related to increasing the yield for publisher or maximizing ROI for our buyers. And we have also seen how we are mitigating infrastructure costs. So thank you for joining us, and the forum is open for Q&A now. Happy Women's Day to everyone. I'll stop sharing my screen.
Thank you so much, ma'am, for such enlightening session. Okay, so now we'll go for some Q&A, and I'd like to hand over to Aparna, ma'am.
Hi Ritika, it was a fantastic talk. Happy Women's Day to you as well. There are a few questions from the audience. I'll read them out to you.
Sure.
First one is, as you were mentioning about the auctions and how the bidding happens, one of the interesting questions is Nobel Prize in Economics for year 2022 was for improvements to auction theory and inventions of new auction formats. Do you use any studies by these laureates in your work?
So definitely, like we are using latest things, but I will like get back to you offline with this question, like what we can, how we are using.
Right. She has. Ask her, are you able to hear me? Ma'am,
Ma'am,
there
there
seems
seems
to
to
be
be
Another
some
question,
technical
Aparna,
issue.
today we have.
Just a
just a
second.
second.
Ask Ritika Surana, did you hear Aparna's question?
Ritika, did you hear my question?
Yeah,
Ritika, did you
Aparna,
hear?
I heard your question. I said I will be, providing more details about it in an offline section.
Okay, okay, that's great. That's great.
Yeah.
Somehow there was some audio issue. Anyway, another question was about someone wanted to know about SSP1. So if you can quickly let us know more about its long form and a quick definition of SSP, it would be helpful.
So SSP is a sell side platform, like we have seen earlier. Like PubMatic is a SSP.
Yeah.
So publishers basically integrates or make their inventory available to SSP, and through this we are able to drive more demand to the publishers in order to increase their revenue or yield.
Regarding the ROI, maximizing the ROI, what type of typical functionalities and optimization techniques you usually use to maximize the ROI? And also a related question to that is there a particular problem faced by your models for getting caught into local minima?
So there are different, campaign goals for different, buyers. So they can be there can be different kind of a campaign goals, which we want to optimize for. Like some of the buyers might look for increasing the CPC or CTR. So it varies from, different customers, like what they are actually looking for to optimize, and there are different algorithms for in order to solve this problem for a different kind of goals. So this is like totally based on like what kind of requests we are getting and how we are optimizing it. Yeah.
Yeah. And while optimizing, have you ever faced of getting the issue of getting caught into local minima often than before reaching to the global minima?
So this depends on like how we are solving a problem. So we are using different predictive bidding algorithms in this space. So yeah.
Okay, okay. Someone has also asked that can you please once again tell what were the models used?
So in the traffic management section, like we are using our custom basically model. Here we are using the reinforcement learning principles in order to maintain the QPS limits for the demand partners or DSPs mainly. So in this space we have our custom reinforcement learning problem, and also in the bidding section we are having our custom algorithm, like we are creating custom predictive algorithm based on like various campaign goals, which we want to optimize for in order to increase the ROI.
Okay.
But
I
we are using multi-arm bandit as a strategy for the exploration and exploitation dilemma.
Okay, okay, it's good to know. I'm sure the reinforcement part must be very challenging in terms of the evolving algorithms and as well as changing requirements by the customer.
Yes. Definitely.
Ritika, I'm sure there are a few other questions which audience would like to ask. So I would like to tell the audience that Ritika would be available for few questions in the lounge. And now let me thank Ritika for this fantastic session. I'll hand over now to my co-host Vedehi, who would be formally thanking the speaker, giving out some announcements, and then concluding the sessions for. Thanks again, Ritika, and
Thank
wishing
you,
you a
Aparna,
very
for helping with all the Q&A section.
yeah, and wishing you a very happy
Great
return.
questions, everyone. Thank you. I'll
Thanks.
be there in the lounge as mentioned.
Vaidehi, so over to you to conclude the session.
Yes, thank you. Thank you so much, Ritika ma'am, to join us today. Thank you for taking our time from your busy schedule and enlightening all our audience, giving insights on the ad tech industry. And we're truly delighted. So, for the entire audience, I have a few announcements to make.
Yes,
So,
Swati.
yes, you're welcome, ma'am. You can all head to the lounge session, to the lounge area, and meet all other speakers, mentors, and participants. And Ritika ma'am will be available on table number 4. So, in case you have any other doubts or you need to, take any advice, so you can please go to the lounge and meet Ritika ma'am at table 4. Apart from that, we have an arena. We have set up about 14 companies who are there on the booths, and you can go to each booth, interact with the company people. If you have any queries, ask about their hiring processes, and yes, you can network with all the other companies too. The track one is still live from Stanford University, so in the upcoming 30 minutes, you can either go to the lounge or to the arena, or go to track one, or you can go to the Aspiring Minds booth and go for the skill assessment test, which is made available by Wits Pune. So thank you so much, everybody. Please come back at 12 noon for the next session, and I'll see you all. Thank you so much for a great session. I'll be ending the session in about the next 5 minutes. Please join the networking lounge, and please join all of the booths and all of that. Thank you.